Welcome back to Easy Academic. Today in the linear algebra series, we'll be going over matrix multiplication. So when multiplying matrices, there are a few things we must keep in mind. Firstly is the conformability of the two matrices. So the conformability refers to how the dimensions of the two matrices relate to each other. So the dimension of matrix A must be m by n, and the dimensions of matrix B must be n by some other value, let's call it L. So what that basically means is that if A is m by n, B must be n by L. And then your resulting matrix, let's call that C, will have dimensions m by L. So this might be a bit unintuitive, but let's use an example to illustrate what's going on. So say we have a example matrix, we'll call it Q, and its dimensions are 4 by 3. We have another matrix J, its dimensions are 3 by 6. Your resulting matrix K will have dimensions 4 by 6. And say J had dimensions 2 by 6, you would not be able to get a resulting matrix. And so let's show how matrix multiplication actually works. So let's take a 2 by 2 example. Let's create a matrix A and call it, or give it the values 1, 2, 0, 3, and a matrix B whose values are 4, 0, 1, 2. So if we want to take A times B, what this will look like is 1, 2, 0, 3, 4, 0, 1, 2. So what's happening when we're trying to multiply these two matrices is we essentially go row-wise and we multiply column vectors. So how does this look? The first entry into the resulting matrix is equal to 4, as that's the element here, times the column 1 times 0 plus 1 here times the column 2 times 3. And that's the first column of the alpha matrix. So we take this column multiplied by this value, this column multiplied by this value. That's how we get the first column of the alpha matrix. The second column of the alpha matrix then is obtained by taking 0, multiplying it by the first column. So we have 0 times 1, 0, and 2 multiplied by this second matrix, plus 2 times 2, 3. And this will give us our final output matrix. So what we'll find is that we have 4 plus 2 over 0 plus 3. That's our first column. And 0 plus 4 and 0 plus 6, which in total will give us 6, 3, 4, 6 as A times B. Now an important thing to note is that matrix multiplication is not commutative. So that means A times B is not necessarily equal to B times A. And so to show this, let's show with the given example again. So let's take BA, which would be equal to 4, 0, 1, 2 times 1, 2, 0, 3. And so applying the same sort of algorithm, we have this entry times this column. So we'd have 1 times 4, 1 plus this entry times this column. So 0 times 0, 2. And then the second column, we'd have 2 times 4, 1 plus 3 times 0, 2. From this we'd get 4 plus 0, 1 plus 0 as our first column, and we'd get 8 plus 0, 2 plus 6 as our second column, which yields 4, 8, 1, 8. And so as you can see, BA is not equal to AB. So if you have any questions, feel free to leave them in the comments. Other than that, this is matrix multiplication, and be sure to like and subscribe, and thank you.